he uploads the receipts, and he goes to an actual physical location. So say he goes to Follett's store, right? Not eFollett's. And over there, say if there's a policy which says that if you've bought a book for greater than $80 from the online or in person, it doesn't matter. So if you have a past purchase of greater than $80, then you can get a particular discount. So to do that proof, we find a way to construct the proof on the phone and provide it to the service provider. And if this proof can be verified correctly, then he gets a discount. So the case is as simple as that. When we implement, yeah.
Is it true that every textbook that Follett sells is greater than $80?
I think that is the case. It's been a while since I haven't bought my own books. Yeah. At some point when you're in grad school, you start getting books from all your seniors and you don't go to the stores anymore. That's a good thing about labs, huh? So when we were implementing this, on the web-based system, there are three main components. We have the registrar, as we talked about. Then in this registrar, the main thing is really just the database where you're storing all the identity records and all that. Identity records and receipt records. We built it on top of the GridSphere portal framework, which is very stable and it provides a good way to extend it. And on the user side, things are very light because you don't have to install any software, because most of the proof creation, commitment creation, they all happen using the applets. The main thing that is really important from the user end is to be able to manage secrets. So we created something called the wallet, which is managed on the cellular phones or on the laptop. But this is the one key thing which needs to be taken care of on the user end. On the service provider end, in addition to what all it has, it needs to have a verifier. So when it gets a proof, it needs to know what to do with the proof. So it needs a verifier component and a proof requester. So typically, service providers don't ask you for proofs. They ask you for your name, your address, your credit card number. So taking a step from that to asking really for proofs instead of the actual identifiers in clear is a big step. I think not so much as from the technical point of view, which we have explored, but there are other issues as well which need to be addressed. So this is the web-based architecture. When we start looking at the mobile phone component, which is mainly the user component, the applets which were highlighted are really done on what are called the phone midlets. So you have we really considered the Nokia phone architecture. So we can run it on top of the phone operating system. We also looked into what are the types of storage and how can we use the tags. There are lots of very interesting details and constraints on how we can use such devices and how they can interact with using their subcomponents with the readers of the service provider. So just a very quick look on how much time it takes. You can see on the x-axis is a number of identifiers that we are proving. These are the multi-factors, the number of factors. And so here you have one factor. Towards the end of the graph, you have about 50 factors that we are proving. And since we had those constant number of exponentiations, over here you can see even with the number of proofs, number of identifiers that we are proving is increasing, there is no significant change in the amount of time it takes to construct these proofs. So we can really take, for the applet, it takes less than 0.1 second, almost on a constant basis, to create multiple proofs. In the case of midlets, it takes not more than 2.5 seconds to create such proofs. Now, if I take this blue line here and compare it to the verification, just in a different scale, so it looks different. But the idea here is that the verification, the server side has a sublinear component where the amount of time it takes slightly increases. But even for 50 proofs, it takes about 0.1 second to verify a particular proof. So those were the main components that I wanted to mention. As a summary, what we really did was to look into a comprehensive solution to privacy-preserving multi-factor verification, which is one of the key components to prevent identity theft in identity management systems. I don't know if this point came out very clearly, but the main assumption here is that data breaches happen. There are so many ways that you just cannot control the compromise of such information. So at the time of use, if we have strong verification techniques, then we can prevent misuse of this stolen data. So you can have multi-factor verification techniques without jeopardizing privacy, and it can apply to various types of identifiers, as you saw in this presentation. So we provided cryptographic protocols for aggregate proof of knowledge, which was the main idea behind multi-factor verification, and we showed how performance, flexibility, and storage-wise they can be used for practical purposes. As well, we provide the algorithms to generate biometric keys. So this is a big research area on its own, but having reliable methods to generate these keys provides a way to use these biometric and non-biometric factors together. So you can use biometrics just as you could use your credit card or social security number, which is very nice. And we show how you can decouple also your actual biometric features from these biometric keys when it comes, and so that it addresses the privacy and some other security concerns. We also provided as evidence some empirical evaluation of our techniques. And finally, for the protocols for establishment and management of history-based identifiers, we showed how to ensure the security and privacy requirements of such history-based attributes. And the prototype implementations were especially fun because they were aspects which have to deal with the dynamism of identity, if you might. And the performance followed through from the cryptographic protocols that we designed. So I actually finished earlier, but okay, I have one more. So future work, I think there might be some students here who are looking at, who are not done yet. So there are a lot of applications of such verification things. So the VeriIDX system, which is really what the whole thing is called, is being used right now. We're looking at applications in healthcare and finance, and the various technical aspects related to, say, the aggregate zero-knowledge proofs. We're looking into some interesting extensions of such things. For example, we didn't consider threshold aggregation. For example, if I want to prove that I have k out of n identifiers are correct, so can I do that? And it's a hard problem. It's a hard problem in zero-knowledge proofs. Similarly, multi-party proofs. If a bunch of friends want to get together and want to prove something together, then doing this multi-factor in a zero-knowledge fashion without really exchanging each other's secret is a very interesting problem in its own. As far as the biometrics are concerned, we are trying to look at extended use of these biometric keys. Like how I use the biometric keys was very specific to what we were doing. But if you had to use the same keys in your real ID, in your passports, or just to encrypt files in your computer, then there might be other aspects as well that we have to consider. And also we're looking into how error correction and machine learning techniques can be used to make these biometric keys much more reliable. In addition, we have this history-based identifiers really do go into the profiling and other aspects which is related to insider threat, fraud detection, and areas of that kind. And over there, my aim was to find some kind of a balance between what information is collected about you and how it can be used for fraud detection and all. And also the mobile identity. Going into the domain of mobile phones and mobile identity itself, there are a lot of interesting applications that one can look at. So that's about it. If you have any questions, you can ask me now, or you can email me later if you think about it. I wanted to put Happy Halloween here, but this thing won't compile. There's a lot, I know, but if there's anything in general also, because the whole thing was motivated from identity theft and what are the real problems, and then again switching to technical solutions, of course.
Any questions? Thank you, Abby.
No problem.